Thank you very much, Fernando, for this introduction, and thank you to all the participants. I see now 17 people listening to what I'm going to say. The presentation we prepared explains our view about energy management systems in buildings, and not only in buildings, also in more complex organizations. The presentation, as you can see, is structured in 5 sections plus one summary. First, I will explain why the Energy Manager is key to be for an energy management system to be successful. Then I will explain the several steps to implement and run an energy management system. And last, I will end with a thought about what one can expect from an energy management system. This diagram structures how we see an EnMS, energy management system. The energy manager is the key figure, who will be supported by tools to implement and run the energy management system, which is composed of several steps: data collection, data analysis, identification of saving opportunities, the improvement program, and finally controlling. Starting with Energy Manager, first of all, very quick thoughts, very quick data points. Buildings represent some 30% of the global energy consumption, according to data from the International Energy Agency in 2011. Also, they represent some 90% of the energy-related CO2 emissions to the atmosphere. Well, first of all, the figure of the energy manager, as I said, is key within one organization or one building to understand and try to reduce the energy consumption. This person will need to make some questions to himself or to herself, like, for example, these ones. How and when do we consume? Meaning in which moments during the day or in which weeks during the year energy consumption is more important in my organization or my building. Where do we consume? So in which parts of my building or my organization consumption is more relevant? This could be, for example, in a certain floor or in a certain facade or in a certain area or department. Also, what do we consume? So what kind of energy, what kind of fuel are we using? How much do we consume? Which is, of course, a very important question. How much energy are we using? And also, very important, what is the cost of this energy we're consuming? So the economic aspect of energy consumption is, of course, at the end, what is more relevant for the organization. So all these questions implies that the energy manager should be knowledgeable about different aspects around energy. This knowledge should include technical, economic, and technological aspects. As we see in the slide, I try to group the different, the set of knowledge the energy manager should have in 3 groups. The first one is billing and energy markets related. For example, he or she should be knowledgeable about energy prices and all the invoicing rules. Of course, he should be aware of regulation, which typically in the energy sector is very complex and very technical and very abundant, by the way. Also should be aware of or should have in-house professional tools for energy optimization. I mean, somebody can use simple spreadsheets, but for some analysis, more complex software is required. And also should be also aware about how to purchase energy in his country. The second set of knowledge should be more technical. This, for example, is understanding which are the trends in energy efficiency. Should have experience with energy audits and overall in energy engineering. Should also be knowledgeable about inefficient or classic or typical inefficient consumption patterns within his or her organization, so that he's quicker and more efficient when identifying potential energy savings. And also should be knowledgeable about electric installations, because at the end this is very helpful. And the third group would be understanding and knowledge about monitoring and control systems, which is essentially what we're going to talk about during this presentation. All these activities, this role, of course, could be undertaken by an internal resource, so essentially an employee of the organization, or it could also be outsourced. Of course, both options have pros and cons. Essentially, if you have an internal person, probably will have easier access to internal resources and maybe money. But maybe it could happen that his authority within the company is not very strong, and therefore will have some difficulties to undertake all the activities he plans to. That is a risk, clearly. An external manager, an outsourced manager, provides certain advantages, like, for example, having better access to more cutting-edge and updated trends and essentially trends within the market, both from the technological and consumption point of view. And also they can provide information or relation with other actors in the industry, like, for example, utility or vendors. This can generate or add value to the organization. At the end, what we see is probably a mixed solution of these two. Probably is the best option, because somebody who knows very well the organization can move within the organization relatively quickly, but having the support of external advisors and expert advisors is also very helpful, as I have just explained. Having said this, we can easily understand that an energy manager should have or should undertake several tasks, which is the ones depicted in the slide. Essentially, should be able to negotiate with energy suppliers, should be able to follow energy markets, should design measures to cut inefficiencies, should be able to detect anomalous consumptions, should select the critical points to measure, should also make an optimal selection of the points of action, should design action plans, and should also implement all the saving measures. Tools for the energy management. As I said, the energy manager should be supported by specialized tools to run his or her work in a successful and efficient way. There are many ways to classify or to organize different tools for energy management. A very evident one could be the one depicted in this slide. Essentially, systems able to monitor energy consumption, and those able to control, let's say, equipment. The ones monitoring essentially collects and provides data on energy consumption or other variables that we can monitor, and of course are very useful to as a base or to create a base for an energy saving plan. While controlling systems are more complex and I mean, they allow to the energy manager to act on equipment, essentially turn on and off the different equipment or even regulate them. Of course, this gives more speed of management and also could generate, let's say, higher efficiencies. Energy management tools can also be classified depending on the degree of control they provide over equipment. We have depicted these three groups, monitoring energy pricing meters, sub-metering, or monitoring and controlling. The first one would be the ones monitoring energy meters. I mean, these are the meters that utilities use to know which the consumption of energy has been over a certain period of time. These systems are very simple, but very robust, and they typically don't require an initial investment. And they provide a good amount of information, but no breaking down of consumption is possible. So it's the first stage, which could be very useful for some organizations, but could be not enough for some others. The second group is the group of equipment or systems able to sub-meter, which is breaking down consumption within the organization. These are a little bit more expensive, but they provide more information, which could be useful if the size of the sites justifies the investment. The last group is the group of monitoring and controlling equipment. This allows, as I said, to not only monitor but also turn on and off the different equipment of the building or of the organization, which is clearly an advantage. But as I said, the cost is relatively high, and well, it's something that has to be taken into account. Some buildings have a specific. Excuse me, I don't know if I missed one slide. Well, okay. As I said, yeah, some buildings have a specific management system, which is called BMS, or Building Management System. This is essentially a combination of software and hardware, which allows to have a good control of the equipment installed in the building. The main objectives of a BMS is essentially keeping a healthy and nice indoor climate, ensure that safety is guaranteed, and try to run, let's say, the building, all the operations of the building in an economic way. The main components of a BMS are these ones depicted in the slide. So essentially, which correspond as well to this picture. So the first component would be the human-machine interface, which is essentially a front end with a display or a control console where the user, the energy manager in this case, could have control of what is happening in the building in terms of equipment. The second one would be the supervisory computer system, which is essentially the central intelligence of the system that receives and analyzes all the data received from the equipment. Third one is the RTUs, which essentially connects or has to do with the different equipment monitored and controlled, same as the PLCs. And finally, the communication infrastructure, which is what provides connectivity to all the system. The most sophisticated systems can map several sites in a centralized way. This can control all equipment, apart from monitoring, of course. The main disadvantage of these systems, which are, from the technological point of view, they are probably the most advanced ones, is that sometimes they are costly. I mean, design it and implement them is relatively expensive. So, one has to make a proper analysis to understand whether this degree of sophistication is required in the organization. In a more analytical way, the main advantages and disadvantages of this sophisticated system are depicted here. Increased energy efficiency, better environmental conditions in the building or in the different sites, a joint management on the different sites or the different parts of the building, and the overall O&M cost of the organization could be reduced. The main disadvantages is that they definitely are more expensive from the CapEx point of view. Also, running this specific system could be more expensive. This is more on the operating costs. They could require certain skills from the energy manager, and certain commitments at all levels of the organization could also be necessary. The different tools that can be used both in single buildings or in multi-building organizations. So this slide is essentially a very simple map of the different options an energy manager can face. As we can see, the building management systems are building specific and include controlling capacity. And in this slide, we want to explain what should be the decision rule for an energy manager when selecting an energy management system. Because today it's very common to see and to get to know platforms and energy management systems because they are very abundant and they are growing a lot, at least over here in Europe. There is like a hype with these systems. But at the end, the important thing is not how technological or how attractive these platforms or the front ends are, but how useful they are for the organizations. And this usefulness should be evaluated in terms of profitability they provide. So, in our opinion, the rule to decide is how energy intensive the sites we are going to monitor or to control, how energy intensive this site is. So over here we try to depict three options, which is sites with low, medium, and high energy intensity. For example, a clothing outlet, which is essentially a shop, which could be maybe 100 square meters or something. They are not very energy intensive, and therefore a single point monitoring system could be probably enough. This system, as we explained with these stars, the investment required is very low, and the amount of information they provide is probably more than enough for such an energy consumption. Larger organizations may require more expensive and more sophisticated systems. For example, a medium-sized supermarket may benefit from having a system able to have a multiple monitoring, so essentially able to break down energy consumptions. While a large hospital or a large factory or a large shopping mall, something like this, probably would benefit from a more complex and sophisticated system able to also control and action machines remotely. So this is a very important message, probably the most important one of the presentation, and also is the one of the key cornerstones in the debates currently in Europe, which is how useful super complex or super sophisticated energy management systems are. Data collection and analysis. We start with data collection. There are three possible levels of data collection depending on the frequency and how measures are taken in the organization. The first one is essentially a simple energy balance, which means trying to understand the energy situation of the building or of the organization by reading and analyzing the energy bills, which arrive monthly. This, together with an equipment inventory and trying to estimate operating times of the different equipment, could generate a pretty good energy audit. Of course, it's not very fast. Of course, it's not very accurate, but it could be enough for certain situations. The second option is creating or building campaigns with mobile systems to have a check and to monitor energy consumption in a building. I mean, this equipment is typically installed for a period of time, for example, 1 week or 1 month, and then some conclusions are drawn from this, let's say, short analysis. This is, a second step, is more complete than the previous one, but still, if we want to have a proper picture of the energy consumption of the building, then we will need to have something more stable which measures every day of the year, so that conclusions, more robust and solid conclusions can be drawn. And of course, the last option is the, let's say, the classic monitoring option, which monitors energy consumption either in a centralized way from the energy meter, or in a more completed or sophisticated way with sensors downstream, and therefore being able to break down energy consumption. Some classic functionalities of monitoring tools are the ones shown in the slide. First one, a monthly simulation of the bill. This is something very useful, particularly for the financial departments, because systems are able to estimate in a very accurate way the energy bill, the monthly cost in the day one of the month after. The second, monthly and annual consumption reports. So this is also useful to have a quick and structured way of how the organization is doing in terms of energy consumption, and also for reporting. Third one, programmable alert system by user. This is also very important because it is a very useful tool to manage the energy consumption. I mean, this alert tells the user when something wrong is happening. For example, when we are exceeding the maximum power consumption, or when we are having anomalous energy consumptions, for example, to avoid penalties. Fourth one, centralized control. This is an obvious one. If somebody can have a centralized and organized view of all the points of consumption, it's of course saves a lot of time. Comparative analysis. This is, I mean, when somebody has a lot of data, they need to understand what to do with this data, and therefore you need to run analysis. One type of analysis which is very classic is comparing, for example, one point of consumption with the same consumption in previous moments in time. This is something that most monitoring tools can do. And the last one is customized data downloading, which is also very interesting because monitoring tools typically allows the user to organize consuming data, consumption data in a customized way. So in the way the energy manager decides is more useful. And then this information can be downloaded to Excel, to a spreadsheet, so that more sophisticated or specific analysis can be done. Data analysis. Once the consumption data has been collected and different energy users identified, data analysis is needed to understand the evolution of the energy performance of the building. And for this, indicators are needed. I would say that essentially two different indicators are useful. One is energy indicators, and the second one economic indicators. And taking into account these two dimensions is what generates the most complete and insightful analysis. Well, this is just an example of a platform analyzing energy data. For example, up here we see two curves comparing energy consumption on a daily basis in kilowatt hours, as we can see, of April in 2013 and 2014. Also, there are some indicators and ratios, and some charts showing how we are consuming and in the different billing periods, etc. Energy management. Identifying saving opportunities. Energy management measures are those in which the energy savings derive from the adjustment of the operating parameters of the equipment without requiring any replacement or including any additional elements. So in this kind of measures, it is not easy. Excuse me 1 second, I think we are missing one slide. Fernando over here. Anyway, as I said, when identifying energy saving opportunities, it is very important to capture or to take into account as many sources as possible. I mean, the different tools is of course the most evident one, but also we can use other sources like, for example, employee suggestions, or we can talk to utilities or to the technicians, equipment vendors, etc., to generate ideas of where saving opportunities can lay. There are two types of setting opportunities. One is energy saving measures, and the second one is energy management measures. Energy saving measures, as I was saying before, are those which typically requires investment in different equipment, either to replace an existing equipment or to complement or improve an existing equipment. It is, well, here we have some examples, like for example, replacing a boiler, installing bulbs, replacing lamps, etc. It is important that all these are properly quantified. I mean, the energy potential of every measure should be quantified so that we can choose which is the most relevant or more attractive one for the organization. Energy management measures typically don't imply equipment replacement, but simply a proper monitor of the different equipment. And there is very important all the controlling measures. Here are some examples. For example, control the supply and return temperatures of air conditioning systems, or controlling certain schedules of the heating circuits, or the the outdoor lighting or indoor lighting, etc. And this, of course, implies a continuous work from the energy manager, of course, with the help of the energy management tools. Improvement program. As I explained, once we have identified the setting opportunities, we need to decide what to do with this. I mean, and for this, we need to take a decision of which energy saving measures should be prioritized. And for this, as I said, quantification is very important. For example, I mean, the calculating the payback periods of each setting measure is probably the most important meter. Over here, we show an example of the payback periods of different saving measures and a potential rule for ranking or for prioritization. So once these energy setting measures are selected, then we need to set up an improvement program. And this, of course, as any program or any plan, should include, well, which activities are going to be implemented, which resources are needed, who is going to take care of that, and how are we going to verify or to check that all these measures are carried out. It is an example, for example, of a form for an improvement program. And finally, controlling. Well, to make sure that all the plan is being carried out properly, it is important to create, for example, indicators or ratios to track periodically that deviations are not significant and that we are following the plan. And for this, I mean, every building or every organization should define the most appropriate one and the most useful one for them. Here we show some classic ones, for example, energy consumption per room, or energy consumption per surface, or per dwelling, etc. it is also important to understand that operational parameters have a direct impact on energy consumption. I mean, it's not only about energy, but also about the running of the building or the organization. Therefore, the main operational indicators should also be taken into account to explain and to predict this energy consumption. For example, it is easy to understand that knowing the production volumes or, for example, number of employees or number of users in a certain organization is something very important to understand energy consumption. Then creating a report is also something very useful and very advisable. These reports should contain information on the evolution of energy consumption in the last period, comparison with reference consumption, and the result of monitoring the several indicators and parameters. Also, economic information should be included. This is also very important, like, for example, the savings achieved or the profitability of the measures undertook. And well, at the end, all the conclusions and all the so what's taken from this report should act as a starting point to start a new cycle of improvement. So at the end, all this should be cyclical and should be a continuous and never-ending process. Well, and once having said this, probably like a final thought on what can we expect from an energy management system. Overall, we should. An energy management system has benefits both for the manager and for the organization. For the manager, we improve clearly energy efficiency. We reduce energy consumption. Sometimes over here it's written 30%. Well, these are in very, let's say, special cases. Then we have a global and all-in-one solution for monitoring and also potentially for controlling. Operational resources are optimized, essentially time consumption, and of course helps to gain a global understanding of the energy situation of the organization, and of course helps, is very helpful for reporting. As for the organization, well, reduction of the general energy costs, reduction of the carbon footprint. It also clearly has advantages in terms of corporate social responsibility, including the responsibility of the employees within the energy consumption. And of course, the value of facilities will be improved. And that's it. This is what we have prepared. Now I will be happy to respond to any questions.